Okay, let us solve this problem. A runner accelerates to a velocity of 4.15 meters per second due west in 1.50 seconds. His average acceleration is 0.640 meters per second squared, also directed due west. What was his velocity when he began accelerating? So let us first begin know the given for this problem. So according to the problem, the runner accelerates to a velocity of 4.15 meters per second. Therefore, this is his second velocity or his final velocity, 4.15 meters per second due west, and a time of 1.50 seconds. His average acceleration is 0.640 meters per second squared, also directed due west. So what was his velocity when he began accelerating? If we are being asked to find his velocity when he began accelerating, therefore we are being asked of his initial velocity. The velocity initial. Okay, let us solve for this problem. Now solving this problem, it's just simple. We just have to use the equation for acceleration. According to our lesson, acceleration is just change in velocity in a given period of time. So our equation for acceleration is Bf minus V initial all over time. Now we can derive the equation for V initial using this equation. By cross multiplication, we will have Vf minus Vi is equal to A times T. Deriving an equation for the initial velocity, you'll have velocity initial is equal to negative Vf plus AT. By eliminating the negative sign, we'll have V initial is equal to V final minus AT. Now using this equation, we can already find the initial velocity or the velocity of the runner when he began accelerating. Let us now substitute our given. So the final velocity is 4.15. Final velocity is 4.15 meters per second. Minus the product of acceleration and time, 0.640 meters per second squared times 1.50 seconds. So by just solving this equation, we will arrive at an answer of 3.19 meters per second. The direction of this is also due west. Okay, so that's just how simple we can solve for this problem related to acceleration, kinematics in one dimension.